In this video, I would like to introduce the concept of absolute convergence. So first of all, we are talking about a series, right? So what is a series? A series is a sum of a list of number, and in the previous lessons we talk about alternating series. So alternating series means you are summing up a list of numbers. So here is how the number goes. So the first one is positive, the second one is negative. So you are adding up positive, negative, positive, negative, positive, negative numbers, right? And this sequence keep on moving forever. So for example, let me give you a series. So we have a sum where n goes from 1 to infinity. I have sine of n divided by n squared. Is this an alternating series? So if you think about the graph of sine, so it goes up and down, right? It goes up and down between y equals to 1 and y equals to -1. So you might be thinking, all right, so sine makes the series an alternating series. But the answer is this is not an alternating series. So let's take a look at the first few terms. So when n is equals to 1, you have sine 1 divided by 1 square. When n is equals to 2, you have sine 2 divided by 2 square. When n is equals to 3, you have 3 divided by 3 square, so on and so forth. But if you use your calculator, set your calculator on radian mode, and then take a look at the value of sine. So sine 1, 2, 3, they are positive. So that is not an alternating series because the first three terms are positive. So when you reach to sine of 4, 5, and 6, sine 4, 5, 6, they are negative. So for your convenience, I already gave you the approximation in orange. So this is not an alternating series. So how do we take care of this kind of situation? So to take care of the minuses, what I can do is I can use an absolute value to take away the minuses. So if you take an absolute value on the entire series, do we agree that every single term will be positive? Because the absolute value of positive is positive, the absolute value of negative is positive. So it looks like if you take the absolute value of the entire series, so that will just take away all the minuses. So let's do it. So we have the sum of the absolute value of an, the last line, do you see that? The sum of the absolute value of an. So now we are taking the sum of the entire series. So sine n divided by n squared, we are taking an absolute value on that. So that leads me to a comparison test. So I am trying to compare the absolute value of sine of n divided by n squared to 1 divided by n squared. Now you might be asking me, hey, I get it, the bottom is n squared because the n squared is way bigger than the sine of n, right? But the top, instead of sine of n, why do you put a 1 in there? So look at the red graph. So the sine, again, is jumping between positive 1 and negative 1. If you put an absolute value on sine, look at the red inequality. If you put an absolute value on the sine, do we agree that all the negatives will be gone? So since all the negatives will be gone, the sine is only the absolute value of sine is now jumping between 0 and 1. So the graph, look at the red graph, is just a bunch of a parabola above the x-axis. So sine is now 0 or positive. Now, using the comparison test, how do you perform a comparison test? You are trying to compare what? We are trying to compare an, right? And then bn. And then which one is bigger? Comparison test. First, you have to show that bn is greater than an, right? So when n is equals to 1, what do we have? We have sine of 1 divided by 1 square, right? So this is 1 divided by 1. And then which one is bigger? This is bigger, right? When n is equals to 2. And then we have sine of 2 divided by 2 square. 2 square, not 2 to the n. 2 square versus 1 divided by 2 square. Which one is bigger? The bn is bigger. So we just show that bn is greater than an. All right. Then is bn convergent or divergent? This series, the summation of 1 divided by n squared, is this a convergent series or divergent series? We are talking about the comparison test. Comparison test, we talked about that in the previous lesson. So this is what kind of series is this? Geometric? Nope, this is a P series. And P the power is equals to 2. So since the power is greater than 1, then the series is convergent. So the series is convergent. So allow me to switch color. So this series is convergent. And then we have Bn less than or equal to An. That means we have a convergent. And then less than or equal to, can this be an infinity? The answer is no, that cannot be an infinity. So that cannot be a divergence. So this has to be a convergent. So that means we just show that the absolute value of An is convergent. So the absolute value of An is convergence. And then what can we say? Now, after this, after you prove that, we can say that in conclusion, the sum of An, which is the sum of sine of n, right? So sine of n divided by n squared, sine of n divided by n squared, this is a new term, is absolutely convergent. And then let me give you the general definition. So here is the general definition. Let me do this in another color. So we say that a series, the sum of An, which is the given series, is called absolutely convergent if the series of absolute value of An, so the absolute value of An is convergent. We just used in the previous example, we just used the comparison test to prove that the absolute value of An is convergent. So therefore, the given series is absolutely convergent. So that is the first concept you have to learn in this lesson. All right, so that will be the end of this video. In the next video, I will give you a few examples for you to study absolute convergence, and then after that, I will talk about conditionally convergent. That is a little bit more complicated. All right, so that will be the end of this video. As always, if you think my instruction is helpful, please like the video, subscribe to the channel, share the video out for me. Appreciate your help as always. I see you all in the next lesson. Signing off for now.